In section 1.3, we are going to be looking at complex numbers. So to visit about a complex number, which is any number we'll see that can be written in the form a plus bi, that is what we consider to be a complex number. We first of all need to talk about the bi part of this, the imaginary numbers. It says so far in our study of algebra, we've worked exclusively with real numbers. Those real numbers are either rational numbers or irrational numbers. However, as we encounter new types of equations, we need to look outside of the set of real numbers to find solutions. For example, the equation x squared equals 1 has two solutions, two things that would check, 1 and negative 1. Because 1 squared gives you 1 and negative 1 squared gives you 1 as well. Now, what about the equation x squared equals negative 1? Can we find one of our real numbers such that when we square it, we get a negative? That doesn't happen for real numbers. There is no real number, x, for which x squared equals negative 1. And so for this reason, mathematicians have defined a new number, I, such that when we square it, that gives us negative 1. So the number I is called an imaginary number and is used to represent square root of a negative 1. It says, furthermore, the square root of any negative real number is an imaginary number that can be expressed in terms of I. If you were looking at section R.3, the review section, and they asked you what is the square root of, say, a negative 9, you just at that point had to say that it was undefined for our real numbers. And that is true. Okay? But now we're going to be able to deal with these animals that have the square root of a negative. In the purple box, we have the definition of an imaginary number and how to deal with it. Here are the two basic building blocks. That I is equal to the square root of negative 1, and instead of having to write 1, 2, 3 strokes of the pencil, we now are able just to abbreviate that and write it as I. That's the very most basic imaginary number. I, square root of negative 1. We also need to know and commit to memory that I squared is equal to negative 1. Now, how we're going to simplify things, such as square root of negative b, or square root of negative 9, for example, that goes into I times the square root of b. Here's how we would look at the square root of negative 9. Okay, this says that it's going to be I times the square root of 9, or 3I. Now what I like to do is use my product rule for radicals and break this apart. Square root of negative 9 is the same thing as square root of 9 times square root of negative 1, when those radicands multiply together to give you negative 9. Square root of 9 is 3. And we know we have square root of negative 1, which the symbol for that is I. That's another way to get that. Let's do some more examples on how to simplify those square root of a negative. For square root of negative 100, like I said, what I like to do is write this as square root of 100 times square root of negative 1. Now simplify each of these factors. Square root of 100 is 10. Square root of negative 1 is I. So 10I is the same thing as writing square root of negative 100, but in simplified form. Square root of negative 63 is the square root of 63 times the square root of negative 1. Now again, anytime you have a radicand that will factor into perfect squares, you want to break that down. For the square root of 63 here, I'm going to write that as the square root of 9 times the square root of 7. And I'll go ahead and say that the square root of negative 1 is I. Now, let's focus on, and remember they had you review this in R.3 as well. Square root of 63 is not in simplified radical form, but when we write it as square root of 9 times square root of 7, square root of 9 is just 3. Bring down times the square root of 7 and bring down the times I. Now, there's really nothing wrong with this form, but what you will see is 3 times I times the square root of 7 in that order. And that is a little bit better just so that we don't confuse that incorrectly. This I is underneath this radical because it's not. That would be incorrect. Okay? So either one of those two. Just make sure that this I doesn't go underneath that square root. On number 10, we've got the square root of 23 times the square root of negative 1 is how we break down the square root of negative 23. This time, 23 does not have any factors that are perfect squares. 63 had a factor that was a perfect square. 23 does not. 23 is prime. So this would be the square root of 23 times I. That's okay. Perhaps a little bit better is I written first and then times the square root of 23. Either one of those two is fine.